Welcome, SpringOne. Welcome.
Welcome.
Are we sleepy after awesome lunch yet? We'll try to, run some blood and maybe give you some interesting stuff, so you probably will not fall asleep. If you will fall asleep, I understand the conference is very long event and people get tired, right? So it's almost third day already. This is event-driven architectures for Spring developers. Let's check if we have any Spring developers in the room. Yay, all right, so we have plenty of Spring developers. Who came here for Kafka? All right, few people. Who came here for a little bit of Kotlin and Spring Kafka integration? Few people, that's okay, that's okay. Maybe Scala people? Out. I'm just kidding. You're good guys. I just don't understand how they mix Scala and Spring, because Scala people saying, oh, we don't need dependency injection and stuff because we have everything there. It's configured. Anyways, so I'm giving to you Gary Russell, software engineer at Pivotal. He's lead on, I think you still lead, right, on the Spring Kafka project. If you ever use the Kafka template, you should say thank you to this gentleman. And my name is Viktor Gamov. I work as a developer advocate at a company called Confluent. At Confluent, we're contributing to multiple open source projects, and one of the biggest, you probably heard about this, it's Apache Kafka, second most active project at the Apache Software Foundation. So, and today we're going to be talking about event-driven architectures, why it's important, why we think it's important. And so let's jump right in. So,
why do we care about this?
Yeah. So, how many of you guys and ladies read the book called "Start with Why" by Simon Sinek? You always need to start with this question, like why are you doing this? Like why you need to know something? What is the purpose? Not how or what, but like why we need this. A lot of interesting things. So, the way how the people perceive certain bits of technology these days might be totally different how we did this like a couple years ago, or even like 10 years ago, 15 years ago. This is the perfect illustration where you just give this weird-looking thing. I don't know where is this. I'm a millennial. I also don't know. I only know phone in the form of iPhone, so I don't know what is it. So yeah, the kids these days, they don't know about this technology because they were not there when it was popular, right? So this is why we can say the world is changing. It's not only changing in the day-to-day things, but show must go on and business must go on, right? When we were dealing with the business and back in the day, now we sound like old people here. So
well, I am
back in the day,
I am old.
Yeah. So IT was never core part of organization. It was a support role, to get things running, right? So to send, so the salespeople will be able to send emails, or some of the accounting people will be able to get some reports done. So things are changing right now, and all companies are becoming a software. So regardless what you do software these days. Sometimes this software can be your core competency, like if you do developing some of the software that you're selling, or maybe service, or maybe some of the cloud, or SaaS solution, or maybe you're still selling licenses and stuff. And if you don't, you probably will use software from somewhere else and things like that. When we're dealing with the data in the past, we try to collect this, and after that, okay, the big data is the thing. We collect the data. We're processing this data. When the night will come, end of day, and only a few companies were doing some sort of innovations because they were disruptive. They're trying to change the world and all these kind of things. These days, if you not innovate, you will lose. You will fail. Your business will fail because everyone innovates these days. Data is moving so fast. Not data. The life is moving so fast that you need to keep up with the data, with the software that you develop. It needs to always innovate. So this is why the old mentality of dealing with data may be not very suitable. So how many of you actually use the taxi these days, like actual taxi? We have a few people. It's okay.
Yeah.
No shame here. It's totally fine. But most of us using things like Uber, right? Lyft, right? Austin, some other things. And because it's more convenient, right? So first of all, for me, it's more convenient because I don't need to talk to people. I just go to my phone and can, like I said, millennials, right?
And you can watch the guy coming around the corner.
Exactly. Like it's like a game for me. Another thing is that these, like in the past, when we were dealing with the taxi stuff, I need to physically to call to office. I need to know the phone number. It's important. I need to use this like black pipe and call the taxi office. I need to know the phone number. Now they need to make sure that if they have a car, so that means that this business is actually involved some of the actual hardware, right? Some of the real cars.
And you don't know when he's going to show up, or if he's going to show up.
Exactly, yes. You can kind of call them and say, yeah, it's going to be here around 10 minutes and like 15 minutes, 20 minutes, he's not there. You call him, oh, yeah, he was stopping by for some burrito and he had a break, so yeah, he's coming. Totally changed the way, right now, the ride-sharing apps totally changed the way how we perceive this service, right? So we now, for owners of this business, they not own hardware anymore, you know? They, I'm not gonna go into some like an ethical aspect of this sort of business when someone trying to sell you something that they don't own and things like that. I'm talking about technology here. So, and this is really fascinating. It's really cool. It allows two people who has cars to connect with people who needs a ride, which is pretty cool. And it's always on demand. I don't need to know phone call. Super simplifies like lives of international conference speaker because I don't need to know upfront the phone number of the local taxi service. I don't need to have a cash that will have exact amount of money that I need to pay within the local currency because everything now is in my device. And it's all about data. This data about my location of the driver. And again, I'm looking and I know where's this driver coming and where we're going in this one, right? So what?
How do we get started?
Yeah.
What enables this transformation?
So the couple things that we learn over the years, there's many things that enable this, right? I just want to emphasize just a few that we think the worth to mention on the technical conference, right? So cloud, machine learning, the mobile, and event streaming or streaming data. This is kind of like 4 things that I want to emphasize today, but there will be more. But this is something that we see is actually drives the adoption of this like fast changing data or like fast data. So cloud changed the way how we perceive data centers, for example. How many of you have seen this? It was a couple years ago. There's very popular like a picture or like a blog post about like things that software developers need to know about latency. And I might be mistaken, but I think the Jonas Bonner from Lightband, he actually used on one of his presentations. It's like he showed the latency of performing operation in the registers for processors, and after that, latency of same operation for performing the memory, on the disk, on the network, on distributed systems, so far and so on. These kind of numbers that the engineer needs to know. So these days with cloud, the most important numbers that we need to know is how much does it cost to get like a bigger, more beefy machines in order to calculate certain things that we're trying to calculate faster. So the way we're not building data centers because it's not our core business. There are companies who core business is to providing this kind of computation services, but as a developers, we don't. If we need to have faster machines, like I want to have a terabytes of RAM to test something, and I need to test it like for a couple hours, and I will just pay only for the time that I use it, right? Now, the way how the decision making, like or not like global decisions, but in general, some of the workflow simplifies with the introduction of the machine learning things. The Amazon was one of the pioneers that allows to drive this retail adoption by offering you stuff that you don't need, but computer thinks that you might need this because he was looking something like this, right? And it also allows to drive business, allows to drive the retail, sales, and stuff like that. We already touched base a little bit about the mobile apps. And on the old phone, you will not be able to do things that you can do on a modern mobile phone, like have a small computer here. And the way how do you generate this data? Most of the time, you generate this data more from your mobile phone, like status updates, photos, some of the tweets, some of the the emails, things like that. And it also streamlines the data. So data going much faster. It's I'm not talking about sizes anymore because we already stopped counting because it's just too big, right? It's just too many things. And why it is important? Why important to have this streamlined data is also it's not sometimes about it's about timeliness of this data, right? So will be information useful to you if this information arrives like 5 minutes later? You can say it's not a big deal, but when you change the context, when you put things in the perspective, if you get information like 5 minutes later about the current traffic that you need to have in real time, like will you still trust this information? Yeah, it was your Hadoop job was computing and almost done to get the forecast or getting some of the results. So this kind of stuff. And we probably see these results like in any other industries, not only in transportation, but in some banking, other places. Mm-hmm. So like these days, you go into places, you need to get the apartment or some flat, so you can go and stay in some awesome place. You go into an app and you book your Airbnb place. Mm-hmm. You're watching some of the interactive movies these days, and based on some of your interactions, you can get different type of content. You're playing some games, and based on your behavior, this heartless machine trying to sell you some other stuff that you don't need, like in-app purchases and all this stuff, like loot boxes and all these things that people buy in these days on internet. Now, I would like to bring this to the point where I would start talking a little bit about cloud, that cloud was a kind of future of data centers, right? So as developers, we don't really care much about like where we're running this stuff anymore. So also the event streaming, that new thing, it will be future of our data. The way how we perceiving, consuming, and processing this data would be in the form of events. And this is a future that we need to embrace, all right?
Yeah, so for an example, I think if anybody was at the keynote this morning, Mark Fisher was talking about in the old days, we would maintain the state of a shopping cart, whereas in this era, we just keep events. I added a book to the shopping cart, I added another book, and then I removed it. So those events can be replayed to reconstruct the shopping cart instead of having to physically maintain state about that cart, and in a highly resilient and efficient form.
If we get another example, like bringing some of the, again, machine learning into the play, the way how the model would be trained to play chess, for example, it doesn't really care about positions of the figures on the board. It actually cares about stream of events, and based on these events, what kind of decisions were made in order to train this model. So to the point where we have a state of our shopping cart reconstructed from the sequence of events that we've done in this store. The same way we're reconstructing the state of our game based on the sequence of moves that we did. So, and you think about this event streaming paradigm is not something new. It's actually more natural to talk about this. It's more natural for human beings to talk about this, and I'll bring some more examples. So essentially, this brings us to the point how we designed applications, again, back in the day, right? 3 tiers applications, front end, some business logic, database. Where we stay the state of the world. It's always in database, right? We put this there. And if we need to add some sort of dynamicities or something is happening, so what will we do? We will introduce some messaging systems. We will try to invoke some other, maybe request response API calls, maybe some of the ETL systems that perform some of the computation for us, right? But here's a very interesting thing, or fairly good and fairly bad, if you look at this one, right? When you're running ETL, Hadoop, and other things, you are dealing with the massive amount of data. Data usually is distributed because it is not very maybe economical to store this in one place. And all the systems, like distributed systems, were designed in some of the startups, in the rise of this like a web scale era. They didn't have money to buy like a beefy hardware, so that's why they built distributed systems to store this massive amount of data. So they provide the ways how data will be stored in multiple small machines. Usually, the system also provides high throughput in order to perform the things. And data is persistent because data is important, data is collected, and things like that. Now, to bring some of the dynamicity into play, we're still using the traditional messaging systems that will allow us to send notification. Like, OK, we need to start some complex workflow that involves some of the computation. Here's a JMS event, right? But apart from speed, we were losing some of the things that this like ATL system will provide, or like the distributed computation system that provides us. And from that regard, the messaging system is just like some sort of glue where we can just one system will notify another system, and this is what we call like event-driven or like a message-driven type of approach for building stuff, right? So the persistency, high throughput, and usually messaging systems are not designed to be like a highly distributed, right? Or maybe very well designed in terms of persistency. Which brings us to the point where we building our applications, and we actually can use this messaging system to connect them, you know, in terms of like how they will communicate, how they will exchange the data, and how the different lines of business will communicate to each other. So one of the like payroll system needs to notify some of the reporting system that something is changed, so they will go and start this batch processing to performing this stuff. Huge mess.
Spaghetti.
Yeah, spaghetti, like Gary's mentioned, spaghetti architecture, right? So not only it's difficult to understand all these data flows, you need to be like very well-versed in this organization to understand. Usually, like in any organization, there's a guy who was there before everyone, and he knows everything, and this is how he has his job security. He knows which application brings data in, which application will use this data, so far and so on. It's not bad, however, we can do better here. So one of these problems, actually, many like a web scale, the startups start facing. They start a process of hyper growing of their organizations. They need to deliver multiple features, and after that, there's some duplication, some consistency problems between multiple systems. So the company like LinkedIn, they start solving this problem the way how they solve and how we know this these days that becomes Apache Kafka is to kind of untangle this spaghetti architecture into the more something that did not exist before. So it didn't, the architecture that will combine best of these worlds, of two worlds, of world of massively scaled systems that allow to store data and process data in the world of fast data where the message would be ingested and things like that. So this is one of the fundamental things that they start looking at and saying, hey, how we can like combine both worlds. So, and which brings us to the new type of the system that never existed before that. That we called the event streaming platform, event streaming system. So when I was talking about the event streaming stuff, I was saying like it's more natural to model this in terms of event, because real life is a set of event.
Right.
Like imagine like you speaking to your significant other, and you say something that you're not supposed to say, and you cannot change this. It's not like a database. You do this update status of wife, where the ID of message blah. No, it's already gone. This event already happened. It might be notification type of event, so just like notify something, so or like trigger something, or it can be a state transfer event. You actually talk about something that changes the perspective.
So
of the
what you
world.
said, like this second bullet here, an invoice was issued. That might be an event that says an invoice, this number is triggered, or it might be the whole invoice.
Exactly,
Yeah.
exactly. So, and these events, when they happen in real life, you cannot change the past if you even you want, but you cannot. So the same way to model system that will collecting a sequence of facts would be immutable, and you can try to do something out of it, right? So essentially, stream, it's a history or sequence of ordered events. They will be stored in this stream platform in the order how they were produced, how they appear in this world. So order is somehow important. Another thing, when we're talking about the modeling system, again, back into the story of the guy who knows everything. Even this guy who knows everything in your organization, he might don't know like something, because the monoliths, the way why we start breaking things down is that monoliths is very difficult to think about this, and very difficult to fit in the head of one person, even smartest person in the organization. Also, it also breaks certain abstraction layers or sudden boundaries, right? When you start doing integration, I'm not saying this all the services will talk to one database. I'm just saying that in organization that was designed to be kind of like a flow of events, like you just give example, like the invoice was posted, it was kind of, and some other like organizational people from different departments will do something. So it's everything flows. But what we end up doing, we're building data stores. Every time we're building a new system, it's a data store, because we need to have some sort of persistency, and we're storing some data, and we're always storing state. So that's why the microservices came into play to weigh how you can decouple the problems, how you can decouple teams so the people can work more efficiently, where you don't need to go through this like huge discussions when you involve like 20 people from different departments and they can't agree, because a different piece of this monolithic application and different departments will be affected if the change will be implemented, and that creates anxiety in developers because they don't want to break, they don't want to get fired because of the changes that they will do. So that's why it brings to the world where we're releasing stuff like twice a year, or maybe if we like it 3 times a year, maybe it was like a bug fix release, to the world where we can release every day and we don't afraid to do that because of the things that we're going to be talking about in this guy over here. We will break down this conversation into like 3 pieces, right? So we're going to talking about these 3 major beats that will allow you start defining your architectures based on this event-driven paradigm. We're talking about pub/sub pattern to accessing this data. Second thing is storage part, because remember when I said about this, the ETL systems and the data processing systems that allows you to store data and make this persist. And now we also need to bring some of the computational aspect. It's cool that we can store this event, we can store stuff in our database, in our place, but it's always good if we can do some of the useful stuff. Now, event streaming platform, there are multiple these days systems that inherit similar capabilities from Kafka. This is appearing these days. Every other month there's some post on Reddit. Someone is just trying to implement their Kafka in their favorite language or favorite technology, or they're changing something and call it as differently. It doesn't matter. So from perspective of event streaming platforms, the three things that they need to be there in order to to form this new category of the software. Another thing that we didn't touch, but it's also very important. Like we, as developers, we're usually very well concerned about performance, speed, and real time. And a real-time aspect is more important, like because data is arriving, you want to know like how far behind are we in terms of processing, like how fast we can react. However, there's another aspect. So real time is good, but there's some information that we already collected, right? The information about, say, some of the history data, right? Some of the information of some of the locations, some of the points of interest that we can combine with the things that real-time data and attach this with some of the context. How many of you ever seen these ads in Waze when you're driving somewhere and you stop your car on the red light, and after that you see this app pop up? Based on your location, based on your current coordinates, they were able to merge this with the information that they get from advertisers so they can display this ad for you. So this is what contextual event streaming application look like. So this is, you've seen this already multiple times. Now you know how it's called, right? And there's other examples. Like we will, we can talk about some other examples where you might enrich some of the data that, like order information that only includes the item ID, but you need to display it in another system that will merge this information with a system that has inventory information. So you have this enriched stream that has this data. Now, we're going to somewhere interesting, right? So we're already, like 20 minutes in, and now like we're going into the point how. Like we started with why, and we get the little bit of historical aspect and a little bit of like inspirational aspect. Now we understand what is it, and now how we can do this. And again, we're going to be focusing on the two things today. We're going to be focusing on Apache Kafka, and we'll be focusing on the Spring Boot as an implementation of this microservice. Though these ideas, these concepts, are easily translated to any language, simply because they are easily translatable to different languages. So let's talk a little bit about different technologies that can enable us. So when I was talking about this microservices world or breaking this monolithic world, that allows us to enable different teams to use stuff. Oh, something is on the slides. To use technology that they like, regardless if different team is using this. As soon as they will find a contract or they will find the ways how they can communicate this between different teams, they will be good. So some teams can use Java, some people can use C++, some people can use, I don't know what, like Go, Kotlin, and other things. So in order to get the idea like how many different clients and follow the same paradigm, you can grab the examples from the GitHub that you can find examples or all possible languages that communicate with Kafka, and they do same things. And they also can, one application can produce stuff, another application can consume stuff. Now, I'll give you just 1 second to take a photo. I'll quickly get back to this slide again. Now, even though we're very proud about ourselves that we're developers and we can write everything, the good developer is lazy developer. Good code is not written code. Like if you can solve the problem without writing lines of code, except the cases where you get paid for the lines of code that you're writing, I also have pointers for you. There's like code generators that can generate like thousands of lines of code. And after that, when you commit this in this source control system, people say, wow, this guy was super productive. It's kind of like super, no, he was probably super busy, but not necessarily super productive. Now, it appears that there are many systems that exist that requires this integration with this thing, event streaming platform, right? So you need to bring this data from Oracle, from Mongo, from MySQL, for Postgre, from multiple places. And it will be wasteful, again, if you not get paid for lines of code, it will be wasteful to just spend the time every time writing this app if you need to do like consuming data over and over from Oracle. So this is why in the Apache Kafka community come up with this idea of Kafka Connect, which is essentially a runtime for connectors. It's like a highly scalable, highly available runtime that allows the people to implement the logic to get data out of some system or put somewhere. So some of the things that we will be demonstrating that follows the similar concept, we will be seeing, but Kafka Connect, this is where you can find all connectors for your system of choice. And you essentially can build event streaming system or integration with existing system without writing lines of code, just installing and activating connector. All right, so, but as a developer, you're focusing on the code, you're focusing on the things that you need to do. At Confluent, we call this like a low-level producer-consumer pops-up API. It's kind of like an assembly language. And thanks to the frameworks like Spring Boot and Spring Kafka that allows to, just simply because you need to, again, write a lot of code just to do like something. You need to configure your producer. You need to be responsible for deserializing your payload because Kafka don't give a, it doesn't care about what kind of payload you're putting inside the Kafka. But with the frameworks that allows you to focus only doing things, like for example, the Kafka template, amazing like performance and like productivity booster. So you don't need to do manual stuff. You can just simply use this and use configuration that you define in file. Or if you do in development, just do out-to-wire Kafka template, and it will use just localhost as a default configuration.
That was a huge plus. When Boot added auto configuration for Spring Kafka, it made life so much easier because we had a set of opinionated properties, and it's just boom, you just inject your Kafka template. And
yeah, sometimes people can say it's like a Spring magic, but once you like us in this room, you know Spring framework very well. You understand what it does, and you can appreciate like a level of encapsulating certain things. So you get things done much faster. And this enables different use cases. We've seen the customers who are running solely mobile applications that using this like similar approach. Automotive industry transforming some of the the software that they use for running this stuff. Last week, we had the Kafka Summit in San Francisco. There's people from Tesla were presenting the way how they use Kafka in their organization to do things, like the magical things because Tesla is a software company that happens to know how to build cars and put the software there. And other, like gaming industry, some other stuff. Now, a little bit more about Connect. Just again, declaratively work with different data sources to bring data in that allows you to integrate with existing systems that don't know anything about Kafka. So you start building this event-driven system, but this event-driven system not only relies on some of the real-time data that maybe your website, like page clicks will generate, but also requires some of the historical data. Maybe you have a mapping between different regions and IP addresses, and based on the information from the clickstream, you want to know what's the demographic of your users. So in this case, some real-time stream goes directly from your application server to Kafka, and Another will come from your database that has this like historical data.
I think it's also important to understand that it doesn't have to be connect on both sides, right? You can have a boot app on one side and connect on the other.
And vice versa. Yeah. So we will be demonstrating some of these things. So one of the things that people usually miss when they asking the question how it's compared to messaging system, because it's still kind of messaging system because it pops up, blah, blah, blah. On the input side, it can be multiple connectors. At the same time, one event can be delivered to the multiple systems, right? To the multiple places. The good example of this would be the way how you read a book, like physical book. Physical book, like me and Gary, we were reading this book, and he's reading this book faster because for me, English is a second language, so I need to use the vocabulary to look up some of the words that I don't understand. But he can read this much faster. My son can read book much faster than me and Gary because he doesn't care about letters. He cares about pictures. He was trying to find the pictures here. We're reading same book, same data source, but different applications that consume this data have a different pattern of consuming this. I'm enriching the stream with some historical data from vocabulary to understand the context. My son, he's just simply doing like a word count or like picture count type of things, right? And we're still working on the same source of truth, like one physical book. All right. So that's why it can be multiple connectors on both sides. And from perspective of deployment, cloud, containers, you name it, fits very well into this paradigm or like managed system, managed cloud, whatever. You can also do small transformation on the real time. So when the data arrive, there's some use cases where you're not permitted to insert data in certain environments. If you have some privacy requirements, like some PII data, HIPAA compliancy, and all these kind of things that you need to take care of, you need to provide special environment. But you don't want to deal with this at this moment, so you can, before data land to Kafka, so you can do some sort of transformation, removing fields, or maybe something more simpler, like using two different databases and the way how different people model these databases back in the day. They use different fields to define dates. So you need to transform this date, and from these multiple sources, you need to turn this in the same format. So when the data will end in Kafka, it will be normalized and will be good to go. So this is where you can grab all sorts of connectors. It's a Confluent Hub. This is the App Store for connectors. Now, second thing is the storage. Now, with Kafka producer and consumer, producer pushes data into end of this, the like endless transactional log, and consumer reading this from the head. This is how this the mental model, very similar to the things that people like about messaging system. It's kind of like ordered because data goes in one place and data reads from another place. However, no one actually considered that this system actually has more in common with distributed databases. And this is not this is the case where I brought the slide where comparing the messaging system. There's not so many things except this pops up thing that Kafka has. Scalability aspect, no one questioning this. Yesterday, LinkedIn just posted a blog post that they are processing 7 trillion messages. Yeah, so they running this in a massive scale. We are supporting the Kafka that runs in the cloud, and we're running hundreds of production workloads, 100 production clusters in the different regions of the world. So a lot of massive scale. Amazing things for people who love tinkering with distributed systems. But there's some use cases where Kafka actually used as like a database. And we're also going to be showing this concept of the compacting topic that allows us to use Kafka as a state store. So this is the blog post that New York Times published where they're talking about how they use Kafka to store the best of the journalism starting from 1851. So all the articles that New York Times ever published stored in the Kafka topic, where the systems like content management systems that needs to display this data or do something with this data, they will be able to reconstruct this and read this from one source of truth that would be a Kafka cluster. So there's a link in the blog post. You can go and check this out yourself. Now, with this approach, we're also enabling multiple systems to communicate using Connect, multiple systems to exchange this information. We can have a state. We can have some historical aspect stored inside the Kafka. We also can have this. Now, let's talk about another aspect, so how we can do something useful with this data. Maybe 2 years ago, we announced this streaming SQL for Apache Kafka, which is KSQL. Different apps can be your processing logic. The Kafka streams, this is what allows to do processing within your application without running multiple clusters, so far and so on. Or if you prefer running distributed systems, running clusters and things like that, you still can run this computational aspect apart from the application logic. So, and I think if you're looking from the top to bottom, this is where we see level of complexity and maintenance, how it grows, because like KSQL allows you get kind of like a serverless approach for stream processing. You just define your stream processing application in the form of SQL, and then this query will be constantly running. Where we're running things inside application containers or applications like a Spring Boot that already covers some of the aspects of deployment, of provisioning this application. We already lots of things covered for us. Not so much when you're dealing with distributed computation things. And the way how it works, it also combines multiple aspects. So when we have a streaming data, the data that goes through our system, we can perform a continuous query that don't need to store the state. Every time we need to do filtering, every time we need to do some sort of transformation, we don't need to store the state. But at the point where we need to store the state, we actually capturing the state in some system that allows us to query the state after. And now it feels like it's not only have a continuous query where you need to have a Kafka or a Kafka client to consume this data because KSQL reads data from Kafka and writes data to Kafka. Now you will be able to perform just a kind of interactive query or like point-in-type query, or how database people call it, query. So because this is how the people like to use this in the database world. So it's not continuous. So we're going to be showing you some of the use case that actually includes multiple interesting components. So first of all, we're going to be listing the changes from the MySQL database. And we will capturing these changes and do some of the computation bits with the Spring Boot. And that potentially will land the Kafka, and the potential enables you to build dashboards and other components. So we will switch.
We need to switch laptops.
Yep, just a little quick. This is what I'm talking about. We're talking about DevOps and the cloud and deployment, but still, there's a thing that works on my laptop, or like works on Gary's laptop. So in this case, we're doing this quick switch. And 3, 2, 1. Okay, you want to do a presentation mode?
All right. So this demo on the next slide, Viktor will have a link to the GitHub repo. This is this demo is sort of three boot apps. Let me go into presentation mode. This is a little REST controller that's capturing updates to currency. So it's a simple app, and all it does is we've got an update and a delete method, and we've got a JPA entity, which is just basically currency symbol and rate. So it's just a very simple app, and all this does is this is right into a MySQL table. In this particular demo, I'm using a component from Zendesk called Maxwell. Is anybody familiar with Maxwell? It's similar to Debezium. Anybody heard of Debezium? Okay. So it basically crawls along the binary logs from MySQL and emits all the database changes as a JSON representation. Add, delete, update. So this is nothing to do with Kafka. This is just a simple boot REST app that dumps those records in.
This is what we call the change data capture. So things that happen in database, and database actually don't know, or this application would not know, that we're capturing some of the changes that happen. So it allows us to decouple two systems, right? So we can do.
So moving on to the Kafka, so what that Maxwell allows you to dump it to various components, and in this case, it's throwing it into a Kafka topic. I'm sure everybody's already raised their hand about Spring. Is anybody using Spring Kafka as a project? Is anybody using Spring and Kafka but not using Spring Kafka? Okay. So
interesting use case.
So the second app is a Spring Kafka app that is basically consuming from that topic that Maxwell is writing to. So as we can see here, this is a Kotlin version. Since Viktor advertised this talk as
since we
as
promised
Kotlin.
some
but,
Kotlin.
But in the GitHub repo, there's both Java and Kotlin versions.
So the good thing about Kotlin is that even though if you've never seen the Kotlin, you look at this one, you understand this. I cannot say the same about Scala. I'm sorry.
So all this app has, it's got this domain object called change event, which is mapped. The Spring Kafka has a JSON message converter that automatically will wire the, because what we do in Spring Kafka is we detect the type of the parameter on the method, and we tell the converter, whatever JSON you get in, try and convert it to this object.
Yeah, so remember what I said about Kafka don't care. Kafka doesn't care what you put inside this because it's just dealing with binary data. But from your application perspective, you do. Right. And like manually, you need to configure all sorts of serializers here. Spring Kafka handles this serialization aspect based on certain heuristics or like logic. So
all this is doing is basically peeling off the changes to the currency table. We don't care about any other changes to the database in this application. So it's just saying if the table has the table name's currency, then write the exchange rate and the symbol to a Kafka topic. If the change data is a delete operation, then we actually send a tombstone record in Kafka. Tombstone record, when we're using a compacted log, which is in this case, the idea is that over time, older versions of that key can be removed, and so when you want to say, well, I don't want this key to exist anymore, you just send a tombstone record, which is null in the value, and then over time, that key will disappear from the database altogether, from the log altogether. And then the third component is basically reading those currency records. And what I'm doing here is I just have a simple in-memory hash map, concurrent hash maps, and then we're basically maintaining effectively a distributed cache of the currency values. So in the old world, you'd have several apps that are interested in exchange rates. They'd have to go do a query on a database to get the current value. Whereas in this case, instead of querying the database, we're pushing the changes via Kafka into an in-memory map in each case. And as we'll see when we get back to the slide deck, you can also do other things like analyze the history of the currency, and sort of graph the rates as they change. So just to show that it actually does do what I'm saying, we can.
Can you do bigger? The font.
Oh.
Command plus.
So we're just doing basically we can do updates. So I'm going to update the exchange rate for the euro, and and then maybe I'll delete the euro. And in the
Command
how do
E,
I get to the
Command
E?
And you should run.
And how do I zoom?
Yeah, you can do just full screen, and it will show in full screen as well.
You mean the presentation mode? Yep. Okay.
And the same thing, you open run.
Oh.
Command E, run, and you will see it on the screen.
Sorry. I'm not an IntelliJ.
I forced him to do that. He's hardcore STS guy.
For it to be Kotlin, Kotlin support in IDEA is obviously better. So you can see here, and I got the tombstone record and removed it from the thing. So it's a very powerful way of improving performance. We've got these change events that are coming from the database, and they're being pushed out to the applications that are interested in those events. I think we go back to yours now.
We're going back
then we'll get the link to the repo.
Yeah. So essentially, with the change data capture approach, you allows to just get data from any source and make this available. One of the hardcore use cases that I've seen in the past, when before I was, 100% committed to speaking at the conferences. I was doing an actual job before. I was the consultant, and I did a lot of professional services with Confluent. And one of the things that we did with some customers were offloading the mainframe data using the connect approach. So that allows not spend the money on licenses, because there would be multiple different system interesting data that will be stored in the old processing, like a DB2 and COBOL-based system. Just this data will be constantly updated from the Kafka that allows multiple use cases to get this. So you can grab this example of the Spring Boot application. Has a Kotlin version, has a Java version.
There is a README that tells about how to get Maxwell up and running, and basically with some sample posts.
So the Maxwell it also follows change the capture aspect. So Gary mentioned Debezium. It's the open source project that their goal is to build the readers for all sorts of bin logs or transaction log of databases. There's a version for MySQL, for Postgres, for MS SQL, for Mongo. So there's plenty of those. And the cool thing about Debezium, they actually wrap this as a Kafka connector.
One other thing to bear in mind, and I've been asked questions several times, well, how do we deal with transactions across all these microservices? And typically, we use compensating. If something fails halfway through, then we have to send compensating data back to the cause that succeeded. The intriguing part about this change data capture is that the update changes have the old and the new values. So it sort of starts to make you facilitate the idea of maybe doing some automation in terms of that. Those
restoring some sort of state on the other side.
Yes.
So once you capture this data in the format that you can easily analyze and make this possible, this is what you can do. Here's an ad example that we're using the thing called Kafka Streams, which is the built-in library in Apache Kafka. So we captured this data into a Kafka topic. Now we're using this combination of Kafka Streams integration and the Spring Cloud Stream. So this is why there's a stream listener annotation here on the method. Also, I didn't mention here, but there's a special type of annotation that allows Spring Cloud Streams to kind of identify what kind of topic would be injected here. I'm just doing this just to illustrate some of the content rather than providing you working code. The code, I should have a link. So if you will follow me, you will definitely get a link. See what I've done? I'm just doing like all these millennials doing, like the subscribe, and I'm a very interesting person. Anyway, now, so cool thing about this about Kafka Streams. If you ever work with Java util stream, you will feel very similar here. Even though it's a full-blown stream processing, for stateful stream processing system, you will understand what is going on here. So as an input, we're getting these pairs of a symbol and a rate, so we can do some of the calculations. So first thing that we're grouping the stream in order to calculate some of the things that we're interested in for particular symbol. In this case, I'm just grouping the key. In Kafka, you probably know this, but it's always worth to mention that every message has a key, it has a value, and a set of headers. So we have access in our DSL to key and value, so this is why it looks like we can use this generic here to do this kind of thing. So we're doing some photos here. Hey. Nice. Well, now we have awesome photos. Next thing is that we're trying to do count, and we're trying to do sum. So in this case, we're using function count that will be calculating count of these messages that arrive for a particular key. And sum is just a summing. The cool thing is that here, you're using this method, but you don't see anything like there's no like explicit concurrent hash map.put or maybe some database insert. Kafka Streams has a built-in concept of state stores that will like capture all this stateful information in the fault-tolerant state stores. By the default implementation, it's a off-heap implementation that uses RocksDB. It's a small embeddable database key value. But also there is a in-memory implementation, and there's a pluggable implementation. You can implement any state store. For example, again, distributed caches would be another example here. So when you run this count, underneath it will create this record and store this in memory. So this is where your stateless stream processing, different from the stateful stream processing, is that in order to calculate next result, you need to have some data from the past. So this is where we're doing, in order to calculate the current step, we need to know the previous one. So essentially here we're doing this previous value plus 1. The same thing with reduce. And one of the most frequent questions that I'm getting asked from people, can we do joins with stream? So this is why I just put this in the slide. So here, this is how we're joining two streams. And technically, it's going to be two tables here, because here, when we're trying to materialize state, we're storing state here. It's not stream anymore. It's a table. I'm doing join this. I am defining what's going to be table that I will be joining, and I'm defining this key, define this value joiner that will provide the logic, what exactly I need to emit in my table that will be produced. And after that, because this result of this join operation, this particular thing, is actually stored in your application memory, so you always know where this computation is happening, because it is a library, it runs inside your application, meaning that you know what is happening here. It's different from the systems where you kind of like submit your job and go figure what node you run your job. And after that, out of this memory, we need to turn this table into the stream and send this into Kafka. So here, we will see a couple interesting aspects. It is what we call stream-to-table duality, or stream-table duality, where we have a stream of data that we can turn in table, meaning that we have a history of the data. We can generate state. And out of this table, we can also get the change events, same way as how we did this on the traditional database, and turn these change events as a stream of updates into Kafka topic. Very easiest way, again, to remember what's the difference of streams and the tables. Remember my example with chess match. When you have all moves that recorded in time based on the certain sequence of things, is your stream. But when you're looking on the position of particular, how you call them, particular figures on your board, this is your table. This is your state. So every time when you're moving something off the table, it generates another event that will turn this table into stream of changes that happened on the table. At this point, there should be GIF with the mind-blowing type of thing, but hopefully it's not that hard. So Kafka Streams, application library that allows us to do like really cool things. get access to all possible libraries that we have. Spring Boot has a fantastic support. There's multiple other components like Spring Cloud Streams that allows you to declaratively configure your application. You can just implement your logic, and after that, using configuration file to specify what topic needs to consume, what kind of serializer to use, deserializer, and so far and so on. Kafka Streams is not just a toy that you can fit in some library. You can actually scale your application. You can run this in the distributed mode, and it's a built-in concept that Kafka consumer group propagates to the Streams applications. Now, using these tools, small applications, you can build this microservice architecture where you driving certain aspects of your application from different points. You have some front-end application that maybe exposes some of the standard like REST API. This is what the pattern that we call single writer. So in this case, data will land through one endpoint, and after that, multiple other systems can derive and do some sort of decisions and react on certain things based on that. So, Kafka Streams also provides the ability to have a state stores, and you can expose your application state. Remember this count, or remember this something. You can actually wrap this in any API and expose it to any system that don't understand Kafka protocol. You can expose it through REST, gRPC, or whatnot. So your application ultimately becomes a database as well. So things what I like to tell about Kafka usually, it's like your database turned inside out, and also it has on the aspect of storage. Your query engine is your application, and your application might have a different needs, right? Remember again my example with how me, Gary, and my son were reading the same book, but we're looking to the different things in this book. Same thing with the Kafka and other applications. Now, cool thing about Spring Framework. What's new in the Spring Kafka?
We wanted to just go over a few of the new. We made a new release last week. I know not everybody's using it, but for those that are, one of the issues, and I have to say that most of these enhancements or changes came about from community feedback. One of the issues we found with the Kafka producer, the Kafka Java docs recommend using a single producer for the entire application. But there's one case where that can be a problem, and that's if one of those users or one of those threads that's using the producer performs a flush operation. Yeah. That effectively stops the world. I mean, so the remaining producers get blocked. So we've now added an option to say if you're in that state, if you are in a situation where you need to flush, then you might want to consider using a producer per thread. We also have this notion of a replying Kafka template. This is for a request-reply scenario where you send a message and you get a future that you then wait on to get a reply to that message. You know, some service receives that message and sends a reply. The @Kafka listener annotation will handle that automatically for you. One of our users came up and said, "Well, I've got a situation where I send a message to a topic, but there are three consumers on it. I want to wait for all three responses." Request reply is a single request, single reply paradigm. So what this guy does is say, well, and you can configure it to say, wait for up to 3 replies or until a timeout, and then you get back a list of replies. So that's kind of a nice feature.
Minimizes the maybe network hoops and latency.
Right. Now Kafka has a notion of a consumer. It's a consumer listener, I think it's called. I can't remember, but it gets back the consumer records. Like when you do a poll and you get back 10 records, the Kafka provided hook gets the whole list of records. We had a user who said, "I want to be able to inspect each record without having to iterate over them."
Yeah.
So that's
usually it's a more reactive approach, and the reactor uses this kind of approach.
Yeah, it's sort of like they wanted to enhance the headers, for example. They want to add a new header or something like that. Yeah. So that's another new feature. This is a fairly minor one. You can now say when the application starts, I want to seek to the last record -1.
Again, it's also like some of the things that I see in frameworks. Like if you develop a framework and you have a little more granular control over the records, is what you do.
Exactly. Other users have said we don't want to, when we finish back handling the results of the previous poll, we don't want to go right around and poll immediately. So we want to just wait some time so they can throttle the rate at which they're consuming records. Micrometer, as with most Spring projects now, we've added micrometer timers so you can monitor the performance of your POJO listener method. We have this notion of seek to current record. So if a listener throws an exception and you configure the appropriate error handler, we'll reseek everything that hasn't been processed, and so they'll be returned. With the previous versions, that was immediately delivered right back. So now you can add backoffs in there. This one's interesting. It's actually the Avro. There are problems with using the Avro deserializer if you have a glitchy network. So when you go to look up the schema, do the HTTP call to get the whole deserialization fails.
Yep.
So now you can just wrap the Avro deserializer in a retry with a Spring retry template, and it'll give you the ability to try the deserialization multiple times.
So the consumers get a lot of attention in this release. So
Yes,
that's why you see
that's
a lot
why
of
it's
cool
more
stuff. Yeah.
In a similar vein to that, the Kafka provides a log and do nothing or a log and fail, I think, exception handler.
Like a
Kafka
failed,
streams.
like throw exception and fail, or throw exception and continue.
Yes, whereas this one gives you the ability to add what we call a recoverer, which is basically a byte consumer that you can then do something like write that bad record to another topic, to a dead letter topic. So that's what the recovering. And we've added a couple of transformers, so you can add headers. So somewhere in the stream topology, if you want to add headers, then we can use Spring expression language to generate the values for those headers. That's a streams transformer. And one more. For those of you that are familiar with Spring integration, you can now invoke a Spring integration flow from within a Kafka streams topology. So you invoke this transformer, invokes the Spring integration flow, maybe goes fetches a file from FTP, and then returns the result. So that's why it's a transformer. And then finally, we have a delegating serializer, deserializer. One of the limits, you've probably seen that there's the KV nightmare. Right? Yeah. If you want a Kafka template, one to send integers and one to send strings, then you basically have to configure two consumers, two producers.
Yep.
Whereas we now have these delegating serializer, deserializer. So you can just say Kafka template object, and the serializer will add a header to say this is a string or this is an integer. So then on the corresponding deserializer can deserialize the appropriate object. So it gives you a bit more flexibility in terms of, again, trying to simplify the configuration.
Yeah. So the things that we, showed and discussed, it's all about developer productivity in building the apps more efficiently and spend more time on implementing logic rather than implementing all this wiring and dealing with the stuff. So now you have this kind of concepts and some of the examples how these concepts implemented in the real world. If you want to learn more about this, there's a couple books that I highly recommend. They're available for free on the Confluent website. So the event-driven microservices, we might still have a few of those books at the Confluent booth. So essentially, it uses the things that we talk about, the Kafka streams, Kafka, and KSQL to build these event-driven microservices. Martin Clapton's book, Designing the Data-Intensive Application, is a fantastic book. It's highly recommended for any software engineer in 2019, 2020. Covers multiple aspects of the modern data systems, including how the consistency algorithms work, how to consensus algorithm works, maybe go in some nitty-gritty details about how serialization in certain formats works, like protobuf and Avro, and why a schema evolution would be important in this kind of world. Plus, if you want to learn something about Kafka, the Definitive Guide is looking for the best book that you can get. And with this, thank you so much for your time. We will have 2-3 minutes for questions. And thank you again for being with us.